Okay, so in this example, we're asked to consider a cable which is wrapped around the inner radius of a spool, and we're told that end A of this cable is moving to the right with a speed of VA. We're also told that the spool is able to roll without slipping on a rough horizontal surface. And given this information, we're asked to determine the velocity of center O of the spool, as well as the angular velocity of the spool. Alright, well to help us out here, we're going to remember that the fact that there's no slip at the bottom of the spool implies that the instant center of the spool is at point C. And if we have that piece of information, it's relatively easy to start to determine the angular speed of the spool. Namely, we can say that that's equal to the speed of point A divided by the distance between points A and C, where I can label point A if you'd like to be right there. And so if I work this out, the omega of the spool has to be VA divided by the distance, which is capital R minus little r. And if we use kind of the right-hand rule on this, we can of course keep in mind that the angular velocity then is going to be given by VA divided by R minus R. And since in this case VA is moving to the right, we know that this rotation is going to be in the minus k direction. So this will give us one of our answers. Now we can also use that to determine the speed of point O, and in this case we know the speed of point O by, again, the instantaneous center rule is going to be equal to the distance between, actually let me write it here, points O and point C multiplied by the angular speed omega. And so if we work this out, in this case this is going to be R times quantity VA divided by R minus R. And so if I want to write this in vector form, I'll have that the velocity of point O is equal to VA times R divided by R minus R in the I direction. I, of course, coming from the fact that, again, given the clockwise sense of rotation, VO has to be pointing towards the right. Okay, I think that about wraps us up for here. From here on out, it's just a little bit of numerical substitution. I know you can do that. Best of luck.